you know when you have like 5 minutes or so,
Okay.
okay? That was, by the way, it was, but now,
You'll each get an hour, right?
Julie was pointing at me that you didn't upload your CV, is that right?
She has.
She has
I
now.
checked it.
Oh, okay, so then
Yeah.
it was out.
Yeah, no, it was. I talked to her yesterday about it. I've done everything except the picture now.
Oh, okay.
I'm a little slow.
She was about the picture.
Okay, so go. I can tell he's.
No, but they have the monitor.
No, I did fake animation in my slide. It looks like a video.
Yeah, it's very professional.
I cannot just see myself walking out of the street.
Oh, that's good, by the way. Yep. You can adjust it. The focus of the camera. Yeah, because this is now this is sort of static.
But then they watched us all behave on Facebook.
That's the important thing.
Okay, so which button is forward?
The green one is forward. The red is backward. So if you press red, you know you're wrong.
Then it will explode in 5 seconds.
Probably should start.
I guess so, yeah. Good to go?
Yeah.
Okay. Good morning, everybody. Welcome to the third IETF update session. And when I say we, I mean Thomas Schmid sitting over there, and I met at the IETF a couple of years ago, and we said to each other, it's a shame that the NREN community is not so active in the IETF anymore as it used to be. We should do something about that. So let's try to get a session together at the Torino conference to get people more enthusiastic about what is happening in the IETF and make them understand that influences their daily job, and they perhaps should be interested in taking part. And I don't want to be as presumptuous to say that this session at the Terrena conference that we put together has made all the difference, but I do notice that there is much more participation from the European NREN community in the IETF at this point. The groups like the AppFab Working Group, EMU, RADEXT, all with a pretty serious representation of this community. So I think that is really a good thing. As I said, third time, and as long as you are happy, we will probably continue in this tradition. Also, if you have the topics that you really would like to hear about next year, let me or Thomas know, and we can try to get you a good speaker. Coming back to today, I think we have managed to get 3 excellent speakers, and I don't want to take too much of their time, so I'll keep it very brief. We have Karen O'Donoghue from ISOC talking about privacy in the IETF, Fred Baker talking about mainly IPv6, but in general his adventures in the IETF, and Alex Band of RIPE NCC to talk about RPKI. So without further ado, Karen, please tell us all about privacy in the IETF.
Okay, I'm here today to tell you a little bit about, give you a little intro to privacy and talk a little bit about privacy in the IETF. I think if you could sum it up in one word, I think this is sort of the year that the IETF really sort of started paying a lot more attention to privacy at the higher levels. There's been a lot of work and individual efforts in privacy over the years, but this is the year it sort of was taken up a level. So to start with, online privacy is the ability to selectively share information within a specific context. It's about appropriate handling of information being shared. It is highly influenced by individuals' expectations. It is dependent on the context that it's in, and there are a number of tools, and in particular laws and technologies, and these tools vary from country to country, which makes it an interesting problem. So the short definition of online privacy is sharing data in a context with an expectation of scope. If you take that a little bit deeper and think about in more depth what the definition is, what type of data are you sharing? It's data that you have supplied, that your service has delivered to you, that's been created externally to you. It can be observable data such as your IP address, domain names, your location. It can also be hardware and software data, the operating system that you're using, the MAC address, any number of things like this. It often has an explicit context, so it can be in a bounded relationship, such as between you and your service provider. It can have terms and conditions like data that you provide to your bank or data that you provide to Facebook. You may or may not have paid a lot of attention to those terms and conditions over the years. There can be limitations on the use of that data by the first party that you give that data to, and also any extended uses of that data, if you think in context of medical data and how that's shared. You generally have a lot of expectations of scope for where that data is going to be, and that may not translate to the reality of how the data is being used. You have user settings like privacy controls and various software applications that you might use. You have service agreements, perhaps between you and your medical provider or you and your bank. You have portability, the ability to transfer data from one context to another. So network confidence is a balance between, how confident are you in the infrastructure that you're using? And the greater the confidence that you have, the more that you will be willing to rely on that infrastructure for things that are vital to you. And there's a real balance between security and reliability and privacy, with a sweet spot in the middle being ease of use. In order to have appropriate, I think every time I breathe it, you need to be in order to have in order to balance your privacy issues, you need basic security applications and basic security mechanisms. In order for the security to be usable, your privacy aspects have to be understood and flexible, and the same holds true for reliability. So beyond the network confidence balance, privacy on a grander scale is really a complicated balancing act. If you look at application functionality versus convenience, the service that you desire versus the privacy implications of those service. If your cell phone can tell you where the nearest Starbucks is, can it also tell other people things that you don't want them to know about you? User control is also another fine balance. We've found over the years, as you're developing security mechanisms and privacy mechanisms, that if the controls for the user, no matter how fabulous the underlying technology is, if you haven't built a user interface on it that the users can understand and that's easy to use, then that technology won't be used. So there's a balance between a level of fine-grained controls versus something that's understandable and easy to use for the consumer. There's also social norms. You know, what's appropriate or acceptable in one culture or religion or generation is going to be different. You know, what a college or a high school student today will do versus what somebody's in their 50s is comfortable with is going to be completely different. And how you balance those and come up with products that are applicable in both environments. There's also sort of the monetary balance. It's if you ask people 10 years ago, are you willing to share your shopping patterns? You'd say absolutely not. And now you take a shopping card that tracks not only tracks what you purchase, but it tracks how you go through the store. So it knows what order you buy things in. And you do all of that for, saving 50 cents off a loaf of bread. So there's a balance there of what you're willing to pay for versus what you're willing to give up to get that 50 cents off. So obviously, in the last year or two, online privacy has become a really hot topic. There's a lot of work going on in the regulatory bodies. This is not my personal area of expertise. ISOC has another couple of individuals that focus a lot more on that. But if you look at some of the things that the regulatory bodies have looked at in the past year, things like the right to be forgotten, privacy by design, privacy by default, informed consent and what that actually means, identification versus correlation. What is the data that you're providing versus what is the data that's being collected about you and correlated from multiple sources? You may not have given a total picture of yourself, but you've given a piece of it here and a piece of it there, and then you put all those pieces together. You get a much broader picture of yourself that you might not have been willing to share. Data minimization, data protection. There's just a whole number of activities that are ongoing. We've seen increased activities. We also see a lot of differences from country to country, especially if you look at EU and the US and some differences there. So what does this mean for the IETF and the IAB? If you look at RFC 4677, which is basically the Novice's Guide to the Internet and the Engineering Task Force, you see that the IETF is a loosely organized group of people who contribute to the engineering and evolution of Internet technologies. And you see that the Internet Architecture Board is responsible for the big picture and for long-range planning and coordination. So why is privacy important to the IETF and the IAB? Privacy has social, regulatory, and technical aspects. And the IETF and the IAB are looking to address the technical aspects of privacy so that the technologies that we develop are deployable on a global scale and still able to address the privacy concerns. IETF technologies have both intended and unintended implications for privacy. There are RFCs dating back to the early 90s that address privacy in the context of specific technologies such as email, SIP, IPv6, etc. There are also there are specific working groups that have looked at technology for, in particular, the GeoPriv, geographic location, and how geographic location information can be transmitted in a way that is privacy preserving. In addition, there are sort of second order impacts. A lot of the technologies that we've developed over the years had privacy implications that when they were originally developed we really didn't consider. The fact that you have a device that is identifiable and that follows you around, it wasn't originally conceived. The way that you identify an address and get data to that device was not originally envisioned as a way that would also be a mechanism that could track your movements. And so these are sort of the second order impacts that we're beginning to understand better and trying to figure out how to properly address from a technical perspective. So what exactly has the IETF and the IAB been doing on privacy in the last year? There have been a couple of advisory groups established. As I mentioned earlier, the Internet Architecture Board is the a higher level body. Higher is not quite the right. It's yeah, there we go. Trying to look further. It's sort of the big picture part of the IETF. And one of the things that they've done, in addition to hosting a workshop I'll talk about a little bit, is they have established a privacy program where they're attempting to maintain focus on the privacy agenda for the IAB. And part of this program is soliciting a number of individuals from outside of the IAB and outside of the IETF with long-term expertise in this area to sort of provide as a group of advisors to the IAB. In addition, the IETF has established a privacy directorate. A number of technical areas in the IETF have directorates, and in particular, if you think about the security directorate, they often review protocols that come out of a number of different areas to ensure that the security experts have looked at these protocols and believe that the security implications have been appropriately addressed. So the IETF is in the process of standing up a privacy directorate that's going to do the same thing. It's going to look at protocols that come out of the IETF and make sure that the privacy implications of those protocols will have been properly addressed. So those are two advisory groups that I kind of wanted to highlight. There are a number of other recent and ongoing activities. There was an IAB privacy workshop, and then there's a number of IETF activities that I'll talk about in a little bit more detail. The first one was the IAB privacy workshop, and the theme of this workshop, it was held at MIT last December. It was jointly sponsored by the IAB, ISOC, W3C, and MIT, and it was looking specifically at how can technology help to improve privacy on the internet. There is, at that URL there's a description of the workshop, all of the accepted position papers. The way the workshop was organized was a call for position papers went out, and from that a selection of individuals was made to get a well-rounded representation. So we would have people from various industries and also people from the policy world versus the technical world. There are also some meeting minutes there. There will be a final report that's in production, but it's not available yet. So that over the course of 2 days, a lot was discussed, but here are just some random questions of the kinds of topics that were discussed at the workshop. At the higher layer, how do we design systems so that they respect privacy? I think historically, we've come a long way, but historically security has always been one of these things where you design what you want to do and then you think about security after the fact. And what you're seeing now with privacy is the same kind of thing where we've designed solutions and then we think about privacy after the fact. And so we're trying to encourage protocol designers to think about the privacy implications from the ground at the beginning. In particular, what kind of guidance can we give specification authors and implementers? Generally speaking, somebody who is an expert in mobility or voice is not necessarily going to be somebody who is an expert in privacy. What kind of threat models should they be looking at? How do we design protocols that don't fall into obvious privacy traps? What are some of the traps that you just can't avoid? And so what you want to do is document the risks, document the problems that you have with the protocol solutions. What are policymakers' roles in these discussions? And, what are the limitations of privacy work in the IETF? If you go back to the, if you think of the privacy problem space as a whole, the technical piece of it's really just one small piece of it. And that what the technical community needs to do is to develop solutions that are usable, but it really takes user education and adequate regulation on the other side to really provide an environment that's healthy from a privacy perspective. I said I would highlight a few specific efforts that are ongoing in the IETF. The first one is the development of privacy considerations for IETF protocols. Just as in any RFC that's coming out of the IETF now has a security consideration section, there is an ongoing discussion about perhaps we should also have a privacy consideration section that would compel the authors to think about the privacy in the context of the work that they're doing. The guidelines to do this aren't completed yet. There's a recent draft that's been released. But the protocol architects have a key role to play in that they need to make a conscious decision to design for privacy, and they need to document the risks. The specific guidance that's currently represented in this document may change, but right now there's a set of questions that it asks the developers of the protocols to think through, what entities collect and use the data in this particular context, what is the nature of the relationship between the entity and the user, what data about the user is likely needed to be collected, and what's the identification level of the data. So this specific set of questions aren't finalized yet, but the concept of having a set of questions or a set of guidance that can be applied to protocol designers in general has been. There's a number of other things that I'd like to mention. The first one is a draft on terminology. In general, terminology in the privacy area is one of these things that's very difficult. I know at ISOC, our privacy team has the technical aspect, and it also has the policy aspect. And it is often interesting to see the material that we write being reviewed by the legal team, the people with legal expertise that are working in the policy environment, because their interpretations and often the words that we use have a completely different context in a legal environment. So this particular document, despite the rather tragically long name, the terminology for talking about privacy by data minimization, anonymity, unlinkability, undetectability, unobservability, pseudonymity, and identity management, is a first attempt at working on terminology. I alluded to this working group earlier as the Geolocation and Privacy Working Group. I've provided links to the charter and to the architecture document, which is currently pending publication in the RFC editor queue. This has been is a fairly mature working group that has done a lot of work in this area, specifically looking at location data and how to manage that. And then is a list of additional interesting documents that might also be useful. In particular, I'd like to highlight the first one, the draft on mobility and privacy. As we move forward and we have devices that are more tied to us as individuals and devices that we do more things with, the issues associated with that are going to need to be addressed. So basically, on my last slide, the key takeaways are that privacy is a complex balance of competing objectives. This environment is growing increasingly complicated with new applications and new devices, and in particular with mobility and how those devices stay with us everywhere we go. The IETF is placing an increasing emphasis on adequately addressing privacy considerations in all of its efforts, and the IETF is always willing to take volunteers to help with these activities. Are there any questions?
First of all, thank you, Lucy. And thank you also for stopping a little bit short. We ran out of time, but I thought it was unfair not to give you your full half hour, but this is excellent. We're back on track. So we have actually time for 1 or 2 questions. So are there any questions?
Hi, I recently read on the news that with some surprise, a large insecurity has been put into IPv6 design because you have now unique addresses again, and the interface identifier may be even built from your MAC address, so you're trackable in every direction. So this was considered on the news as a failure in the design of IPv6. How would you comment on this?
We had that discussion about a decade ago.
Your mic is...
I'm happy to hand this over to an IPv6 expert.
Well, so the day that Network World published that article about a decade ago, I happened to show up at Purdue University to talk with some professors there, and walked in and spoke with some people from the IT department who were just absolutely giggling about the entire discussion. And then they told me why. The thing was that the previous week they had a student have their NIC card stolen, and wireless NIC. So the student happened to know their MAC address, and so they looked in their logs and they figured out what IP address it had been using, and looked around in their DHCP logs and found out what address it was using now. Went from there to the what access point it was attached to, and went over by that access point and found the NIC card. They were able to do that with an IPv4 address. And they didn't need the MAC address to be built into the IPv4 address to do that. Okay, what they needed was the logs and the correlation of information. So yes, the original design of RFC 4291 puts the MAC address in the form of an EUI64 address into the MAC field, but you can also use privacy addresses, which are random numbers. You go ahead and do it. And the thing is, understand that those logs exist and they can track down if you steal a NIC card.
I just want to add one thing to that. I am actually one of the authors of the draft BRIM Mobility and Privacy, and I do believe there is a problem with some of the protocols that have been designed recently, because they tend to do something like publishing the MAC address or the EUU address that is typically the MAC address with some bits around it. So if you have a global mapping in DNS from that persistent address to an IP address, you will be able to track the user where he goes. And I do think that is a problem. And Fred points out you can use privacy address, but that is often not the default. Actually, Microsoft by default does do privacy addressing, but most OSs don't do that. So it is something to worry about, I think. Did we take all your thunder away, Karen?
Oh no, I'm happy to defer to IPv6 experts.
There is one more question.
Grigory Sakian, Armenia. You told about the difference between definitions, which are terminology in in IETF and in terminology in real life. Do you see any type of conflict here?
Do I see a type of conflict? I think any time that there are different. Anytime there are terms that are used differently in different contexts, it is a cause for confusion. I think the IETF is early in its investigation of what terminology is appropriate in this environment. And I think we're going to have to spend a lot of time looking at the legal community that has spent that has a much more mature set of language associated with it than what the technical community currently has with respect to privacy. Oh, please.
So, Karen, your actual statement was not that the IETF had a set of words and real life had a set of words. It was that your legal people had a set of real words.
Yeah.
And I have an interesting example of the conflict between the technology people and the legal people within Cisco. Because we're on a committee together and supposed to figure out how to make certain things work together from a patent law perspective and so on and so forth. And, well, let's start out with the term IP. You know, it of course means intellectual property, right?
No.
Okay, I mean, many of our words overlap and have really amusing conflicts like that.
Right. I think the important thing is to add as much clarity where those differences occur. So, you know, any effort that helps people better understand what the other set of people are communicating is helpful. But I also think that terminology is something that you can spend an awful lot of cycles working on. So it's one of these things that you really don't want to get to the point of the best solution. You really want to get, you've made an improvement, and you can cycle back to it again some other time.
Okay, thank you once again, Karen. On to the next speaker, so if the people behind can switch the presentation. I'm going to just use the time until Fred is up and running to talk about it. You can read all speakers' biographies online, so I'm not going to just read that out from a piece of paper. Suffices to say that Fred has a long and distinguished career in the IETF from the early days of routing and switching protocols to the adoption of new IP protocols that ended in adopting IPv6 in the end, among a number of alternatives. And Fred is currently co-chair of the IPv6 operations working group in the IETF, and he will share with us some of his adventures in the IPv6 space. So take it away, Fred.
Great. Thank you, Klaus. So privacy considerations for this talk. Privacy was not considered in developing this talk. Okay, now there's a lot of things about the IETF that I could talk about that I'm not going to go into today. What I'm really going to talk about is my own particular work over the last couple of years, which involves being co-chair of a working group, and of course then the work that's done in that working group, but then also some specific technologies that I've been involved with. So let me talk for a minute, or well, several minutes actually, about IPv6 operations, what we call V6 Ops. V6 Ops is intended to be a place where the operational community and the vendor community and of course the research community can meet and talk about the intersection of needs and solutions in the IETF. And we've seen over the last 4 or 5 years a really material change in the attitude toward the operational use of IPv6 in this working group and in the IETF. To pick a very well-known example, RIPE 53, I believe, October 2007, there was a song that was put together by a bunch of the guys kind of lampooning IPv6 and saying, well, I suppose we ought to take a look at it. You know, life's going to fall apart one of these days. We ought to know what they're doing. And then over the time since, we've seen the operational community become very much more concerned as the IPv4 address space ran out. So I was met with the CTO of a company whose name you would recognize in 2008, and he was very worried. He said, you know, we know we're going to have to switch to IPv6. We don't think the content people are going to do so in time. You know, can you tell me that the content people will be on board? And what are the OSS issues that we're going to have to deal with? What are the software issues we're going to have to deal with? 2009, 2 years ago, we had several operators come to the IETF and say, this is how we're performing our transition. We'd like you to talk this through, document that in an RFC so that we can talk about that and be able to buy the stuff from our vendors. Over 2010, we've had a concerted effort from operators in the IETF community talking about their issues and their needs. And it's very much gone from lampooning the subject in 2007 to in 2010, 2011. We're deploying, here are our issues, and okay, so where do I get this, and how come this doesn't work with that, and so on. Specifically, the IETF meeting that we had in Beijing in November, we had a convergence of people coming into the room and very concerned about their transition plans. And in part, we could say, you know, the reason you're having this problem is because you didn't start when we told you to start. And so now you're having lots of problems. Gee, we wish you had started when we told you to start. But, you know, China Telecom came in and in so many words said, in 2 years, we're going to have an IPv6 only network. We're right now an IPv4 only network. How do we get from A to B? And, you know, what are the things we're going to have to do? Telstra was talking about dual stack with carrier grade network address translation, free, and most recently, just last month, Swisscom, talking about using 6RD as a technology to work over DSLAMs and other equipment that are difficult for them to upgrade. You know, they were all coming in and saying, oh no, the manure is about to hit the fan, and we've got a problem, and what are we going to do about that? The meeting that we had at the Hilton, 4 kilometers from here, just at the end of March, those same operators were in and talking about their issues, but very much more consciously saying, okay, we're in a process of making things happen. We have the content providers on board. This transition is happening. It's fully underway. And now we've got some other issues that we need to deal with. We find that some of our users are using older technologies like 6-4, which was really built as a prototyping technology. And that doesn't work very well in the network that we're operating in. And what are we going to do about that? And, you know, so really taking fairly conscious steps to make sure that IPv6 not only worked, but worked really well and delivered a service that, that their customers would find useful. Now, at the same time, we've had an influx of operators coming to the IETF and looking at specific privacy problems and wanting to generate them, okay? What the Chinese frankly said that they wanted to do was encrypt a user's identity into the interface identifier in his IPv6 address and therefore be able to track any user's communications anywhere in China. And we said, could we talk? And so we set up a working group to talk about that and have been looking at how to do source address validation, which is to say that we know for sure that the source address is actually a system that's somewhere in the network and that you're not spoofing the address without encoding the identity into the interface identifier, okay, without doing those kinds of things. So this is something that has been brought by the operational community and requested basically because we have this technology in IPv4. As they move into IPv6, they want to have the same kind of technology. And looking at both the auto-configured addresses with Slack, with address auto-configuration, and then also with the HTTP assigned addresses, which are possible but not widely used in IPv6 networks. The discussions of transition, it seems like in the IETF I have historically kind of every so often hit a working group that draws grad students out, and we get, when we were doing differentiated services and trying to figure out how best to queue traffic, I would get mailed papers, and here, if you use this algorithm to schedule your traffic, life will be better. No, if you use this algorithm. No, if you, and just one after another from grad students. We've had this problem with the transition technologies at this particular juncture. We have at least 3, I think 4, different transition technologies that the IETF has not chosen to adopt that may have value, may have particular places where they're being used. And I get people knocking on the door of the working group saying, can I talk about it in your working group? Because nobody else will listen to me. And well, maybe there's a reason nobody else will listen to you. But, so myself and Jari Arko in the IPv6 operations working group put together a quick document describing what the IETF's viewpoint on the transition is. And to begin with, I'm very careful with the use of the word transition or the word migration. To me, they imply 2 things. They imply turning IPv6 on and turning IPv4 off. And at some point, we will in fact turn IPv4 off. But that's not something I'm worried about right now. Right now, what I'm worried about is turning IPv6 on. And then at the point where there's no business case for continuing to use IPv4, I think it'll turn itself off. People will decide they don't need to worry about it. Okay, so the fundamental viewpoint that we put together in this draft, which is about to get published as an RFC, what the point is that we make is, to begin with, the issue is not which transition technology you should use. The whole point is to turn on IPv6. Why don't you start from there? And then in the course of doing that, you're going to run into some places where it's difficult to upgrade a particular piece of equipment that you need to upgrade, and you need a workaround solution until you can upgrade that. Or at kind of the other end of the process, you'll want to keep IPv4 alive, but maybe not throughout your network. And how are you going to deal with that? Okay, so look at appropriate technologies for making that happen as you do so. And the question really is, what are you connecting? Are you connecting 2 things of the same kind and talking over a different kind of a network? Or is it a matter of having to translate? And of course, if you're translating, then you're going to have to use translation. Okay, but the basic technology recommendation that we made was to move away from exploratory technologies towards supportable technologies, and to do things that were relatively simple and consistent and made sense. Okay. One thing that I spent a fair amount of time working on was this matter of translation. And understand that the IETF as a general practice really, really, really doesn't like translation. Like really, really, really doesn't like translation. But there are some cases where it's frankly unavoidable. And so we needed to be able to describe a technology that could be used for a period of time in order to enable that to happen, and be able to specify what the issues with it were so that people would know and be able to deal with it. And of course, the fundamental thing is that IPv4 was not designed with a variable length address and was not designed in a way to be easily upgradable to another protocol. To change it out requires a whole new protocol. So there is no real way to have interoperability between v4 and v6. And the translation technologies that we've put in place have distinct limitations. Okay, so do they work? Yes, they work. But they work if you understand the limitations. And the limitations are, it's really difficult to fully specify a 128-bit value in 32 bits because you're missing 96 bits. And so the stateful translation going from an IPv6 domain and placing a session into an IPv4 domain, that works just fine. You can do the same thing we do with v4NAT, and that works fine. But opening up a session from a v4 only domain into the v6 domain and talking to any device in there winds up requiring a fair amount of technology that has been proven to not work very well. So we wound up simplifying things and just saying, you know, that's the case that we're going to choose to not solve. And instead of solving that, we're going to encourage you to turn on IPv6 in your network, and then you won't have that problem. Okay, so yes, we have translation. It has limitations. And the limitations are in part about what happens with your applications. For example, with file transfer, FTP. The people that did the IPv6 upgrade to FTP had the brilliance to change the command for, what do they call the mode? Where it doesn't change the session. I'm sorry? Passive mode. They changed the passive mode command. And so in order to upgrade FTP, we have to go change the passive mode command in flight. Who thought of that? I don't know. But you know, so there are some issues that have to be handled with an application layer gateway of some form. The tunneling discussions, we have a wide variety of tunneling technologies in the IETF. We have 6-to-4, we have ISATAP, we have Teredo, we have, of course, standard point-to-point tunnels of various kinds. We have, in addition, 6RD, which could be described as 6-to-4 fixed. And we have 4RD and a couple of other technologies under discussion. One of the things that we've had a number of papers on observing is issues with undesigned tunneling infrastructures. So if I have an infrastructure that tunnels automatically from point A to point B and then has to come back in order to get to C, from a routing perspective, you can wind up with some fairly random routing behavior and random quality of service delay and loss characteristics. You'd really like to be able to engineer your routing. And so we're recommending in general that people move away from the technologies that have been used for exploratory use and for prototyping technology, and move toward technologies that are really designed for use in native deployment. Now, one of those is 6RD. That was put together by the French Telecom Free. And like I say, it builds on 6-to-4, but makes it a carrier service that is actually pretty supportable. And Swisscom recently announced that they're using that across their network to deploy IPv6 as a service without having to deploy it as an infrastructure. Now, to give you an idea of how that's intended to be used, Comcast started in June of last year and deployed 6RD in a number of places in their network so that they could get over kind of older equipment that was going to be difficult for them to do an IPv6 upgrade on. And they've said that June of this year, they plan to withdraw all of that. They will have, in the meantime, upgraded all of that equipment, which in some cases meant purchasing equipment or at least putting in some new software or something like that. That's the intended use of these transition technologies. It's not to put something in and now we've got it fixed, we'll just live with that forever, but to provide a breathing room to deploy the service and while you're doing the work under the covers. Okay, so the IETF is looking at 6RD as a primary mechanism for working around of IPv4 equipment that's difficult to upgrade. And then at the other end of it today, looking primarily at DS Lite as a way to tunnel IPv4 over IPv6 during the shutdown phase of IPv4. We're also looking at a couple of other technologies which we've got operators coming back and telling us that this will be easier for them to use. And that's a discussion that's ongoing. Now, the final issue that I'm going to look at is multi-homing. About 2 years ago, NTT came to us and came to the IETF and told us that they had a very material problem in deploying IPv6 in their network. And that was that NTT operates, as many companies do, a DSL infrastructure that front ends a number of service providers and needs to be able to be used by them in appropriate ways. And they might have multiple service providers in the same home where you've got roommates that have services from different service providers. In addition to that, under Japanese regulation, television is moving to an internet base, and so they have another ISP that's operated by NTT, but it's kind of a public use ISP. And what it delivers is video content, okay? So if you want to watch the TV in Japan some number of years from now, you will almost by definition be running video over IP into your home, and that coming from a certain service provider. Well, what that means is that every home in Japan is by definition multi-homed. And the multi-homing behaviors of IPv6 in such a situation weren't all worked out. Specifically, how do we make sure that we know that we're using the right address in order to talk to the right ISP? How do you handle routing? How do you handle a number of the issues related to multi-homing in a multi-homed residence? So IPv6 ops, MIF, several other working groups, of course, IPv6 maintenance, have all been looking at different aspects of that problem and trying to make sure that the right thing happens. So it turns out that we have, in the industry right now, we have 3 different basic solutions to multi-homing that are being kicked around. And let me just kind of bring you up to date on where we stand on them. The IETF's basic model uses provider allocated addressing. What we suggest is that the residence that wants to become multi-homed, or the SOHO, or smaller company that wants to become multi-homed, should get its prefix from its provider. Now, I was fairly careful in not saying the really big company. And why? Well, consider my company. My company, Cisco, has 100,000 employees. We have locations worldwide. We have some 30 different places where we connect to about as many different ISPs, in many cases to multiple ISPs at the same DMZ. We are as big as most service providers. When we run, our IT department is essentially a service provider within the company. So from the perspective of a company like Cisco, if it makes sense for a service provider to have their own address space, it makes sense for Cisco to have their own address space. When you talk about your top, Fortune 1000 companies, that's probably true. You're looking at companies that are in a category where they really kind of deserve their own address space. But there's a lot of pressure in the RIRs for, just allocate provider independent addresses to everybody, and then everybody will be happy. And they keep pushing on the RIRs to say, so can you give them to this class? Can you give them to this class? Can you give them to this class? And the IETF is looking at it and saying, well, if you're not one of those really big companies, you really should get your addresses from your ISP. Now there are some issues that brings up. Of course, it deals with the route table bloat in the default free zone. That's a good thing. But what it means is that the edge network is in some sense captured by its ISP. There's a certain amount of control that the ISP can apply now to the residence or the small home or small office. And in many cases, people would like to be independent of that and to not have to renumber their networks when they change. Okay, so that's the IETF's viewpoint, and there's an issue with it. Now, what we see in the network operational communities, as I said, is pressure to go to a provider-independent model. Speaking as a vendor, speaking as someone who makes equipment and would like to sell it to people like you, I'll build anything you want to pay for it. Okay? How much memory you want me to put into it? Consider that we have individual chips that have 500 CPUs on them, each one of which has to have some amount of memory. Think about the implications. It becomes a question of heat, question of power, question of data center design, question of operational and capital expenditures in the equipment that you buy. You know, how badly do you want to go? You want to put order of 10 to the 7th, order of 10 to the 8th addresses into the route table? We can handle it. The technology works. Do you want to pay for it? That's the question. Okay, so what we see in the network operational communities is a fairly consistent push in the direction of PI, and I'm concerned about the endpoint. Okay, so, well, it turns out that I've been working on a solution to that, which allows for independent addressing at the edge, and at the same time makes it look provider allocated as it crosses into the transit domain. And that involves translation of not the IPv6 address, but the prefix part of the address at the boundary between the enterprise network and the transit domain, the upstream network. Since the packet crosses the boundary into the transit domain and gets that particular ISP's prefix put onto it, there's no question now of BCP38 ingress filtering, because we know that address got put on there, or that prefix got put on there. And it now looks in the core as if it literally came from that ISP. It has some limitations, of course. One of the biggest being that if a session moves from one ISP to another, it's changed its address. And, well, you know, that session's going to have a problem, at least with TCP as it exists today. A solution to that would be multipath TCP, of course. So this is a solution that we're publishing as an experimental RFC, and we're starting to see some products around. This kind of makes the PA-PI choice moot, because you don't need a PI address in order to be independent of your ISP. And at the same time, you get the benefit as if it was a PA address. Okay, so, there's a competitor to the technology that I developed, Margaret Wasserman and I developed, and that's ILNP, which was developed in the routing research group by Rian Atkinson. So, you know, there's that approach as well. So this is a technology that I think will allow us to make multi-homing a lot simpler, and without some of the big issues of heat, power, and that kind of thing. There is an issue at the application layer. That is that when it makes a referral, you'd really like it to use a domain name as opposed to specifying an address. 2 minutes? Okay. Well, it just so happens that was my last slide. So, okay. Yeah, so quick questions, one or two, and then we'll move on.
First of all, thank you.
Certainly.
It's great to have these experienced speakers in your session, that you don't have to be policemen. Are there any questions for Fred? Even better.
Hello, João Nuno from Portugal. I'd like to know if you have something to say about the IPv6 operational problem of the browser's fallback delay time and
Okay,
the eyeballs proposal. How is it progressing through the browser manufacturers?
Well, so I was actually about to take that to working group last call, not now, but next week. And Dan and how many of you know what we're talking about? A few. Okay, there's a problem with most operating systems that they put the choice of the address that you connect to in the application. And the application tries to connect to one address, waits until TCP times out and fails, and then goes to the next address. And it may never get as far as switching from IPv6 to IPv4 or from v4 to v6. Or it may simply take a long time being on the order of minutes. Okay, so different operating systems have different parameters, different applications have different parameters, but that's the fundamental problem. And Andrew Yurchenko and Dan Wing wrote an internet draft which they call Happy Eyeballs, pointing out the problem and suggesting the fairly simplistic solution of why don't you try multiple TCP connects in parallel and open them up at a certain rate until you get one that works and then use that. Okay, so where we stand with that, Dan tells me that they're working with vendors. At least one operating system is carrying the solution of that into the operating system to make it easier for the application to just always do the right thing. And one hopes that if one does it, then the others will as well. He expects that he'll be kind of at the end of his process in August after the next IETF meeting. He'd like to have a discussion with the operators and with various communities in wrapping that up, and then we'll turn that into an RFC. The application work, as I understand it, is going on kind of as we speak. So.
Any more questions? One over here. And that's also the last one.
George from Portugal. I'd like to know what is the status, the development status of the CPE routers basic requirements for IPv6, basic and advanced requirements. I know that this is in draft stage. But
yeah. So for everybody else's benefit, this is a document that was brought by 2 Cisco employees that were working with Cable Labs. They wanted to incorporate the requirements of the broadband for them and basically set forth a set of specifications for a broadband CPE router. Now, we broke that into 2 drafts, kind of things that we knew how to do at the time and things that we were going to have to go think about. And the first one actually was just published as an RFC. It got its RFC number, so it's out there. The other one is still in the process. It's accreting kind of things that people would like to have in it. And we have some work in the IPv6 maintenance working group, which we're going to need to come back before we can really put that out. But that's ticking along. So.
Thanks again, Fred. Our last speaker is Alex Bond of RIPE NCC, one of those evil regional internet registries that want to take away the provider-independent space from nice companies like Cisco.
Really?
But Alex is going to talk about RPKI, a way of associating certificates with resources on the internet. So, Alex, take it away.
Okay. Yeah, like I said, my presentation, well, by the way, I'm Alex Band, product manager at the RIPE NCC. So I talk about this stuff very, very often. And I'm actually responsible for the design, the actual implementation of the IETF standards. So we have within the IETF, they come up with great ideas, and they write very long internet drafts and RFCs on it, and then it's essentially up to all of the corporations and the internet community out there to turn that into an actual service or into an actual product. My job within the RIPE NCC is to do that for, one of the things is for resource certification, so there. So my talk today is about internet routing today. And internet routing largely still consists of random acts of kindness. You know, everybody knows that you have several networks on the internet. The internet is just a network of networks, and they communicate with each other through routers at the edge that do route announcements. You go to your RER and you say, well, you know, I'm an independent company. I would like some provider independent space, as this goes, you know. It's actually interesting that you brought that up, Fred, because if you look at our membership, we have more than 7,300 members, and this is increasing still with hundreds and hundreds of new members every year. And if you look at the size of these organizations, most of them, they fall in like the small to extra small category. So they have something like a /24, /21, /20, that kind of order of magnitude. The amount of corporations that actually have a very large amount of address space is maybe just 100 or so. I think the top 100 of LARs have almost half of all of the address space that the RIPE NCC has ever handed out. The reason why I bring that up is also because this has implications on this kind of service and this kind of routing. Because routing today is completely open, non-hierarchical, free. You get your addresses from your regional internet registry, and then you start announcing that on your router. But there's nothing stopping you from announcing a block of addresses that actually isn't yours. And if you do this maliciously, it's called route hijacking. If you do this unintentionally, it's called route leaking. And this happens every day. This happens every day. And it is just that you have a very tightly knit community of network operators that all know each other, that these problems are quickly alleviated. So somebody makes an announcement, and then a couple of minutes later there's a post on IRC or a blog post or an email to Nanog, hey, I'm seeing this, what is happening? And then people manually put in filters to filter out the rogue announcement. So the problems are really dealt with in like an ad hoc way. There's also a system in place called the Internet Routing Registry, but that is a very distributed system. There's like 34 internet routing registries that contain so-called root objects. And the root object says, well, from this autonomous system, I will be announcing these prefixes. But the problem with the internet routing registries is that we have security built into the RIPE database. So the RIPE database is pretty secure when it comes to that. So only the legitimate holder of the address space can create a root object, because it's completely locked down through maintainers and authentication. But that is not the case for all of the internet routing registries. So there's no way to completely trust the data. If you aggregate all of the information from all internet routing registries together, and you look at all of the root objects, then not even half of all of the prefixes that are out there, all of the announcements that are out there have a root object attached to them, and from the ones that are there, from the root objects that are there, there's no 100% guarantee that the information is actually accurate. So this problem, as with all of these things, the problem itself was identified somewhere in the 90s. You know, as with IPv6 and with DNS problems and the implementation of DNSSEC, it's all 90s technologies. And then it takes, well, almost a decade for it to turn into something real. And you see that with DNSSEC. How long did it take for the root to be signed? You know, how many top-level domains actually have a signature attached to it right now? And then if you look at these top-level domains, you know, .nl is signed, .se is signed, .co.uk is signed. how many ISPs are actually standing there with their DS record in their hands, knocking on their TLD's door going, I have a DS record, can you please add it to your zone? It's still a lot of work, and the progress is fairly slow. So we tried with certification to create a system with resource certificates, attaching a digital certificate to an internet number resource. And an internet number resource is essentially just a fancy word that we use for an address block, IPv4 or IPv6, or an AS number. All of that together is what we call internet resources. And with that certificate, you can actually do fancy things, because you can make attestations about what you're going to do with your address space, something that other people can actually validate cryptographically. Well, and that is actually what the RIPE NCC does, because we are the authority on who is the registered holder of a block of addresses. And all of that information is kept in our registry. And we have yearly contact with all of our members, because they pay their fees, we know who they are. So to a large extent, we're actually very, very confident that the legitimate holder is actually the rightful user of a block of addresses. Not for everything. There's a lot of provider-independent space out there, and we're trying to establish a contract with all of those holders of provider-independent space to make sure that we know who they are, we know who that user is, and then we can also issue a certificate to them. So that is what we do. To every legitimate holder of a block of addresses that we know who they are, we have contact with them, we now issue a digital certificate. Now, having a certificate in itself isn't that interesting. It's only interesting when you start doing something with it. So what we want to do is to make internet routing more secure and make the registry itself more robust. Because right now, if you say, well, I am actually the rightful holder of this block of addresses, here, go and look in the RIPE database, then it's just a piece of text sitting in a database. That's sort of the only proof you have. Now you actually have a digital certificate which you can use for that. And the system that we use is based on open IETF standards coming out of the Secure Interdomain Routing Working Group. And they've been working on that for, well, like I said, almost a decade. A lot of work being done by people like Dr. Stephen Kent, Randy Bush, George Michelson, Jeff Houston, a lot of people being very active in this field, trying to get it to work. So the system that we have, the system that the RIPE NCC and the implementation that we're offering consists of two parts. The legitimate holder of a block of addresses can specify their routing policy. They can say, I authorize this autonomous system to announce these prefixes. And then the other side is actually validating that information. So publishing routing policy is one end, and validating that routing policy is the other end. And this, up to now, hasn't been possible at all. So you do this through management. And I've done DNSSEC trainings, yeah? And I've done them for LARs. I've done them for ISPs. And if you look at the tooling that is out there for DNSSEC, there's not a hell of a lot there. So I was standing there with a whiteboard explaining how to do a manual key rollover in DNSSEC. And then by the time I was at step 12, wait for the time to live to expire, and then move on to step 13, most of the people in the room are like, yeah, that's an awful lot of effort for something that I don't really suffer from a day-to-day basis. I realize that DNSSEC is important, but if I look at the amount of effort that I have to put in to make this work, I don't think I want to do this yet. Maybe I'll just wait for my TLD to be signed. Maybe I'll just wait for the root to be signed. That was a couple of years ago, and now that moment is there. So what we wanted to do with resource certification is actually build a hosted system, a system where all of those crypto operations are taken away from the user, and we do them for you on a hosted platform. And you just have a web interface in our portal on the RIPE NCC website, and it does all of that for you. Now, any security expert would say, now that's not a very good idea now, is it? Because you have a certificate and you generate it on your system and you store it on your hardware security module, and there's like no way for me to retrieve it. I am not the holder of my own private key. That's not a very good idea. Well, it's a trade-off. We consider it to be a trade-off. We said, okay, we realize that a number of users out there, we have 7,300 members, that a lot of them will say, yes, this routing security idea is good, but if I need to run an entire infrastructure running all of this cryptography, taking care of all of these key rollovers, then I don't really think I'm going to participate. So what we wanted to do is build a hosted system and have a non-hosted system where you run all of those crypto operations yourself for the larger ISPs, like those top 100 that I talked about. So this is all open source and this is all open standards. So there are several implementations of that software. So the hosted platform is something that is only for the RIPE NCC. You can only access it through the web interface. But if you use the non-hosted one, you can use a package that is ours, but you can also use stuff that was made by ISC, for example, and BBN is also has an implementation. So you go in there, you have your certificate, and with that certificate you create root origin authorizations. So all this system does is lock down the root origin. It doesn't actually do path validation yet. That work within the CIDR working group is going on now. They're rechartering themselves. All of the work for origin validation has been done, and now we're moving in the direction of getting path validation locked down. So in a number of years, you'll see an implementation of that. So once you've managed all of your root origin authorizations, you publish that in a public repository. So there's a repository out there that has all of the authorizations in there. So this autonomous system is authorized to announce these prefixes. That is all. And other people can validate that information. And validating that can be done through a RIPE NCC validation tool or a third-party validation tool. So there are several options to do that. So, like I said, a valid ROA can only be created by the legitimate holder of the address block. And that is really what the regional internet registry locks down. And that's a bit, people are a little bit hesitant about that. There's a lot of people that embrace this idea, but they're also like, yeah, well, I thought the regional internet registry was only supposed to be involved with ensuring uniqueness and distributing IPs, and you didn't have anything to do with routing, right? And now, well, we're partly involved in routing because we're locking this down. In the same way, we lock down who can create a root object in the RIPE database. So it's, in some cases, it takes a little bit of convincing. Let me show you how it works practically. So we have this web interface, and you can click on Add root origin authorization, and you can fill in an AS number, give it a unique name, and then just drag in one of the certified resources that you have on the right. Now, these resources, that is what we get from our registry. So this LAR, this ISP, only sees the prefixes that were assigned to him by the regional internet registry. He can try to fill in a different prefix, and I'll just throw him an error message. You can also fill in something called a maximum length, and that is for purposes of deaggregation. So if you want to say, I authorize this AS to only announce this particular prefix and no more specific. If he announces more specific, I'm going to regard it as invalid. So you can actually lock down deaggregation, which is pretty good for the routing table and gives the holder of the prefix a little bit more control over what he authorizes different ASs to do. You can also fill in a start date and an end date, if you want. So you can, for example, take care of transitions from one AS to the other. So this information is valid until the 31st of March, and as of the 1st of April, this new information will be valid. So you can sort of anticipate that kind of thing. So all changes and all changes and updates are automatically reflected. You have a web interface you can browse, and all of the machine access is done through the rsync protocol. Now that's interesting because this technology is actually being built into routers. because there's a so-called RPKI RTR, or RPKI router standard in the CIDR working group. And this is being pursued by Cisco and Juniper. So they will actually have products that support this. I'll explain to you how that works a little bit later. So we had all of this done, and we've been working on this for quite a number of years. And then I thought, and I sat there on the 1st of January, we're going live. And then I thought, how many people are actually going to use this? You know, because I was expecting sort of adoption levels that rival DNSSEC and IPv6. You know, it takes years for something like this to gain a little bit of traction within the industry. But then this happened. That was unexpected. That little spike that you see at the end, that was the RIPE meeting last week. It sort of works like that. So you explain it and people go, oh, that's actually a pretty good idea to secure routing, and it's fairly easy to use. I could just put in my routing information. Now, if you look at the amount of people that actually start validating this, actually start depending on this information, that's a different story. But now there is like a base set of information, and we can start working from there. And this is good, because now we can gather feedback, start looking at the data in the repository, start having a look at people are just playing. And whether they create ROAS for everything, because that's an important thing. If you create a so-called root origin authorization object for one AS, and you forget to create it for another AS, all of the announcement that that other AS makes will be regarded as invalid. It will be seen as a hijacking attempt. So when you start putting in your ROAS, you have to be very meticulous in making sure that you've done all of it and you don't forget one. And in case you're wondering who these people are, they're actually these people. That really surprised me. It's some of the bigger ISPs are really embracing this as a thing they would like to pursue. So there's a lot happening in this field. And now we finally have some standards and an implementation that actually starts working. The amount of address space, so these companies that I just showed you, and the 460 others that didn't fit on the slide, they created ROAS for 174,000/24s. For the people that are good at math, this is about 2.5/8 worth of address space that now has a valid root origin authorization attached to it, and about 8,400/32s. That's pretty good. Because now we can do something. Now people can start validating. Because we need to gather community feedback now. Now we have some data, now we need some ideas. So if you have ideas, we'd love to hear them. If you need a certain implementation, we'd love to hear about it. We're building a non-hosted solution so you can run your own software. Now, of course, people need to be able to script against this, and people would like to have an API that is exposed, that kind of thing, really practical things to fit it into the workflow that people already have. And the way we need to build that, that is what we're contacting the community about. So if you have any feedback on that, I'd love to hear it. If you'd like to cooperate in building this, I mean, it's all open source. I mean, you can really, we can really collaborate here. It could be a joint effort. This is what we've come up to now. Out of everything that I've learned over the last year, what we want to do, what we've done actually, is implement a so-called up-down protocol. This makes it a distributed system. This allows you to run a non-hosted platform yourself that securely interfaces with a RIPE NCC, so you can set up your own so-called certificate authority. And we're releasing our client software as a pilot. And this is all open source BSD license. Then, and that was a really, really interesting suggestion that came out of the community. What we want to prevent, of course, is data rot. What you see with the internet routing registries a lot is that people put in a root object and then they just sort of walk away and forget it and they never update it. So what we want to do is build an alerting system using the root collectors that we have. The RIPE NCC also operates those. So they are a really global snapshot of what a BGP routing table looks like. And you can start having a look at whether the ROAS that people create actually match real-world routing. And if they don't, it gives you an alert. So if you're no longer announcing a prefix, or if someone is announcing a prefix that isn't theirs, or if you forgot to authorize a certain AS, it can all help you. It can also suggest ROAS based on root collector information. And we want to work on caching, scripting, API, and router support, that kind of thing. Like I said, Cisco and Juniper, we're actually actively working with Cisco to make this work. We have a couple of Cisco 7200s at our office running beta code. Now, the way this works is that the router will be able to ask a question. The router itself doesn't do any of the crypto. So the router will say, I see this announcement for this prefix. Can you tell me if that is a valid announcement? And then the validation service, so this is a separate service running off the router, will answer with 1, valid, 2, invalid, or 3, unknown. I have no idea. This doesn't exist. There's no ROA for this yet. And of course, right now we're in a situation where unknown will be the most prevalent state, but valid and invalid will be things that will be increasingly available. And based on that, based on the 0, 1, or 2 reply, you can create route maps, you can make a decision. So all of this is to drive routing preferences. Network operators are free to put in any routing policy they like, and other network operators are completely free to base any routing decision that they want on the information that is available to them. And the simplicity will be in the fact that this will be, well, completely from generating a certificate all the way down to being available in routers. So that's happening. And if you need anything else, if you want to know anything else, please go to ripe.net/certification, or you can also contact me. Or if you have any questions now, let me know. See, it worked out with my timing.
This is really brilliant. I could become a full-time session chair with speakers like this. Are there any questions over there? Do you have a mic?
Ooh.
Oh, you have it already.
Hi, Turan, Finland. What's your plan with ERX?
Ooh, that's a nice one. Yeah, so just to be clear, in the beginning of my talk, I said we certify all of the address space that we have established who the legitimate holder of the address space is for. So right now, we only issue certificates for IPv4 space that has a status provider aggregatable or IPv6 allocated by RAR. Those are the only two. For provider independent, we have a so-called policy that was started a number of years ago where we're trying to establish contact with the actual end user. So they needed, the sponsoring LAR needed to submit a contract. And once we verified that contract, you know, the end user identity was established. There was a contractual relationship. We could issue certificates to that group. For ERX, we would actually have to bring them into the registry, which currently isn't the case. And we're looking at that for the end of the year to set up a sort of a contract system where you could bring your ERX space into the RIPE NCC registry, which would be good, because if you start looking at this from a malicious point of view, then when IPv4 addresses are depleted, the chances of people just using some address space that they go like, well, let's have a look at a whois database somewhere. No, let's have a look in the root collector somewhere. I don't see this announced anywhere. I'm just going to use this space. So bringing that ERX space into the registry, you could legitimize that this is actually yours. What kind of membership or what kind of fees or what kind of contract, it's still to be decided, but it's definitely on our list of things we want to do.
One question about the general development. I mean, you were mentioning these are open standards. Actually, they're not. They are not standardized to some extent.
No, yeah, they're right.
And they're not finished. I mean, the RTR protocol is under debate. So do you have any view on how this will continue? How fast will you catch up with changes in the specs, and
We are.
How much do you take part in the discussion?
The lead developer on our RPKI software attends all IETF sessions. So he is very involved in the discussion. We also make sure that everything that is discussed in the CIDR working group and all of the changes within the internet draft that is made is actually implemented within our software as soon as possible. Most of the standards that really define the infrastructure of the service, that is all in last call, and it's essentially waiting for it to get an RFC number. So then it should become pretty solid. With regards to RTR, we still need to start development on getting that. I mean, like I said, maybe the Ciscos that we have, I couldn't even call it beta code. It's more like alpha code. So by the time it gets, yeah, but from Bertrand Duvivier. So yeah, we'll get to that. It's all very fresh, and there's also a lot of discussion about legislation as well. Because I wanted to mention that because of course now, when you're a certificate authority and you start issuing a certificate, then law enforcement and governments, they wake up and they go, hey, you issued a certificate. That also means I can revoke it, right? And that's a little bit, that's a discussion that we're also having. Because under Dutch law, there's really not anything. We operate under Dutch law, of course. There's not really anything you can do to revoke a certificate. And then even if you would, I mean, other network operators are just like, well, you know, I know it's an invalid prefix because it was revoked by an LEA, by law enforcement, but I'm still going to accept it anyway because I'm just going to whitelist it. So those are all the hot topics and things that are happening right now.
Thank you once again, Alex. People are coming in for the demo, so I think we'll have to end the session here. I was asked to make a few announcements. In the breaks, there are demos in Zenit, as you can tell, and Taiko. Don't forget to look at all the fantastic posters that are out there and talk to the people that put them up. And tonight there are a number of BOFs and workshops, so have a look at the schedule and see if there's anything of interest to you. With that, I want to thank you all for coming to this session, and please one last applause for our three great speakers.